Hello everyone, welcome back to the channel. Today we are going to learn about the designing algorithms. Imagine we have a messy pile of books on our table and we need to arrange them so fast. How do we decide the best way to do it quickly and correctly? That's exactly what algorithm design is all about. It's the secret recipe behind solving problems step by step, just like a pro. By the end of this lecture, we will understand algorithms with simple real life examples. So even if you have never coded before, it will make total sense. Let's dive in. First of all, let's understand what is designing an algorithm. Designing algorithm is the process of creating a step-by-step method to solve the problems quickly and efficiently. Think of cooking rice. We follow the steps: wash rice, add water, cook, and wait. That step-by-step method is an algorithm. For algorithm to be good, it must follow some rules, some properties. First one is the correct. Correct means it always gives the right result. For example, if a calculator gives wrong answers, it is useless. Second is the efficient. Efficient means it saves time and memory. For example, taking a shortcut instead of a long road. Third is the finite. Finite means it must stop after a limited number of steps. For example, if traffic lights never change, cars will never move. And fourth, it must be well defined. Well defined means every step must be clear and understandable. If instructions are confusing, even humans make mistakes, and the computers do the same. So, every program is a practical implementation of an algorithm. Now, let's understand the steps involved in designing an algorithm. The first step is to clearly understand the problem. We must know what is the input and what is the output. Just like in exams, if we don't understand the question, we can't solve it. Next, we select the right algorithm strategy. Choosing the wrong strategy can make a simple problem very slow. This step decides how good or bad our algorithm will be. After selecting a strategy, we write the logic using pseudocode or flowcharts. This helps us to understand the logic before writing the actual code. Now we check whether the algorithm is correct. This means checking if it works for all possible inputs, not just one case. Now we check whether the algorithm is correct. This means checking if it works for all possible inputs, not just one case. After correctness, we analyze the efficiency. We check how much time the algorithm takes and how much memory it uses. This helps us to know whether the algorithm is practical or not. Finally, we optimize the algorithm. Optimization means improving the performance by removing unnecessary steps, using better logic, and reducing the memory usage. Let's now look at some common algorithm design techniques. Brute force. Brute force means trying all the possible solutions. For example, linear search checks the elements one by one. It is easy to design but slow for the large data. Next technique is the divide and conquer. Divide and conquer divides a problem into smaller parts, solves them, and combines the result. A very good example is the merge sort. Greedy technique. Greedy algorithms choose the best local option at every step. An example is the Kruskal's algorithm. Greedy algorithms are fast, but they don't always give the best global solution. Dynamic programming. Dynamic programming avoids the repeated work by storing the results of subproblems. A classic example is the Fibonacci sequence. Backtracking. Backtracking means try a solution If it fails, undo it and try another. Common example is the n-queens problem. Branch and bound. Branch and bound improves the backtracking by eliminating the useless paths early. It is commonly used in optimization and job scheduling problems. So choosing the right design technique greatly improves the performance. Now, characteristics of a good algorithm. A good algorithm should have optimal time complexity, minimal space usage, good scalability, simple and clear logic. So to summarize, designing algorithm is about solving the problems efficiently. Every program starts with an algorithm. There are clear steps in algorithm design. Different problems need different techniques. Good design leads to fast and reliable programs. Now, here is a question for all of you. If you are given a problem with large input size, which design technique would you choose? Comment your answer below. I hope this lecture helped you to understand the algorithm design or designing an algorithm in a clear and understandable way. In the next lecture, we will learn about the growth rate of a function. See you in the next lecture. Thank you for watching.